Hi, Dhruv. Thanks for joining today's session. Let me introduce myself briefly. I do have around 9 years of experience in total IT, and for last 7 years, I am working as a data engineer. In my current company, I'm working as an assistant manager. Mostly, I work in AWS cloud. Also, I have expertise on Azure. So mainly creating the data pipeline, collecting the requirement from the clients, understanding that, and distributing to my colleagues how to implement that optimization techniques, etc. This is all I'm doing. So you can also start with your introduction. Let me understand the last project you are working on, the tool you are comfortable with, so that we can have the discussion going forward. Yeah.
Sure. So I have around 2.5 years of overall experience and in big data domain. And I initially started my career at Infosys, where I was working the Azure data stack. So I have been working on Azure Data Factory, Azure Databricks, Synapse Analytics, as well as Spark and Python and SQL for our processing. And here I worked on two different projects. Both of them were client-facing projects, and the second one was a really huge project. And after that, I recently joined Impetus around 6 months ago, where I've been working as a Databricks engineer. So here I mostly worked on Delta Live tables and autoloaders and how we can optimize, how we can use them efficiently.
Could you please explain the project you are currently working on and what is the business problem you are solving?
So currently, actually, I'm into Gen AI right now. So we're sort of transitioning towards that. I'll go over my previous project where I was working as a data engineer. So here, in my previous project, basically, we had a client for whom we were creating these pipelines. So our client had these third-party partners for whom through whom they were generating some revenue, and these third-party partners had daily transactions coming in for us, and through these transactions, our client was generating revenue. And basically, what we had to do was we had to ingest these transactions on a daily basis, and then basically calculate royalties on top of it, which the client had to pay to these third-party vendors. So this was on a very high level what we were doing there. So yeah, like I mentioned, we had around 10 partners. For 10 partners, we had 10 different one data pipelines. So this pipeline, what it will do, it will ingest the transaction data on a daily basis. We already had our metadata placed in our storage location. So we would process this data against this metadata. Everything was actually configuration driven here. So if there was any change in requirements like data quality checks or any business requirement change, like for example, we were using this streaming data. So like for example, whatever someone has watched a video or not, and whether they have watched 10 seconds more than not. So if they satisfy this particular condition, only then that particular transaction will be considered for royalties. So we had different conditions like this for different partners. So this was just for one of the partners that I mentioned, for one of the entertainment partners. We had different partners for different streams as well. So like we had a search engine partner, we had a fashion partner, and all of those things. So yeah, our job basically was to ingest this data on a daily basis and then do all this transaction processing that I mentioned. And based on these transactions, we will then send our data to an on-prem SQL database where our calculation engine was there. So this calculation engine would then perform the calculations on top of the processed data, and then it will send it to the SAP for the billing and analysis. So here for the whole orchestration, earlier we were using Azure Data Factory, but recently we sort of moved to Azure Synapse Analytics. So all the newer partners that we were onboarding, we were onboarding in Azure Synapse Analytics, as well as the older partners. We are also working to move it to Azure Synapse Analytics only. And for processing, we were using Azure Databricks for ADF, and in Synapse, once we moved to Synapse, we were using Synapse notebooks only. And PySpark was the main language that we were using for our data processing. So in this data processing part, we had like an orchestrator notebook, which would then run 5 to 6 different notebooks depending on different partners. So these 5 to 6 different notebooks would be data quality checks, column transformations, business logic check or pre-processing restatement, things like that, based on the business requirement. Most of the partners followed the same pattern, but for some we had a few different pre-process and post-processes. So the idea here actually was that the main code, majority of the code should remain the same, but as and when we need to like onboard a new partner, we would just need to update the configurations and then create a new pipeline based on the same code, but like different configurations. And then we would be able to process the onboard the new partners. So that is why everything was sort of configuration driven and everything was parameterized, every pipeline and everything. So yeah, on a high level, this is.
Just a couple of questions. You have told that previously you were using ADF as an orchestration tool. Currently, you moved to Azure Synapse.
Yeah.
So basically, ADF is orchestration tool. Synapse is kind of warehouse, or you can do ad hoc query, right? These two tools can't be compared.
No. So Synapse provides the whole capabilities, like it provides ADF pipeline capabilities as well as the warehousing capabilities. So actually what happened was, like I mentioned, we had this on-prem database, right, where we were sending our data to. So this was sort of a bottleneck in our project because this calculation engine that we were using, it was on-prem. So to avoid that, we sort of moved to Synapse, because in Synapse we can use these database data warehouse to create external tables or views. And then we sort of created another calculation engine, which would then take the data directly from these views. Instead of sending the data to on-prem, we would directly take the data from these views and external tables. So that is why we moved to Synapse.
What is the total size of data you are dealing with?
So like I mentioned, we had different partners, right? So for different partners, we had different sizes of data. So this ranged from around 1 GB of records per day to 200, 300 MB of records per day.
So these are scheduled job or triggered job or on-demand basis?
Everything was triggered, like scheduled. So a couple of partners were daily transactional based, and a couple of partners were weekly transactional based.
Okay, and what kind of file formats you are receiving in these files?
Yeah, so for some partners, we were receiving it in an SQL database directly. So we had an SQL database that we were ingesting data from. For some partners, we were receiving CSV files into our storage location, and then we would then convert it into Parquet. And then for some partners, we already had some other data lake storage account where we would directly take a Parquet file into our system.
Okay, and have you involved any kind of PySpark job optimizations?
Yeah. So yeah, like I mentioned, for this we were ingesting transaction data on a daily basis, but this transaction data was actually really huge, and the metadata that we had was really small. So when we were performing this joins operation, we were using the broadcast join optimization in Spark to quickly do that without to avoid shuffling and all. And apart from that, we also use the partition by clause to store our data in a structured way. So we used we partitioned by year and then month, because we were also querying by month very often. So every single data table that we had in unprocessed as well as in the processed directory, it was structured in such a way. And apart from that, we also used the delta tables instead of Spark tables. And we used because to update and merge efficiently, we were using this. And even for restatement, so sometimes what happened was when we used to get transactions, but it was an updated transaction. On the same ID, we would get different records. So for these particular records, we used to perform the upsert update operation in delta tables. And yeah, I think these are the techniques that we have used.
Suppose whatever the existing pipeline you're currently working, suppose one day you logged in your server and you are seeing that you're getting out of memory issue for the Spark jobs, right? Maybe the data size is heavier than you used to get, whatever, or maybe something changed in the configuration. So what kind of steps you will follow that troubleshoot this kind of error?
Yeah, so I would first of all look at where we're getting this error from, which step exactly. And then I would try to see what exactly, like you mentioned, maybe we would be getting a bigger data set like than what we usually do. So in this case, uh, first of all would be identifying the root cause, what is causing this out of memory error out of a sudden. And then second step would be like we will try to just see what we can do. Should we just directly increase the size of the cluster, or should we perform some optimization to reduce maybe we can filter the records, or maybe we can add some condition before we are doing that thing where we are getting the error. But of course, if we are performing this filtering or anything like that, then this would change the whole pipeline. So we would try to avoid that, and then we would mostly just look at the size of the cluster.
You mentioned, right? First of all, we will find it out from which proportion of that code is breaking. So how will you identify that location in that huge code repository from where the error is coming out? How will you find it out?
In Spark UI, we can check where we're seeing this error. And like we can follow the whole tag, and then we can see, okay, this was the partitioning here, we are partitioning here, we are maybe caching the data frame here, we are doing this. So mostly out of memory error we would get when we are trying to cache something, or if our data is skewed. So if our data is skewed, in that case, we would try to repartition our data frame that we have, or if we have whatever the issue is, right? We try to resolve it in that way. If we are caching and then we are getting out of memory error, then we can maybe persist our data frame or things like that.
You talked about the data skewness, right? So if you find that for some, maybe the data, whatever you are supposed to get, but the data, whatever you are currently getting, for a particular partitions, you are getting huge amount of data. Suddenly it is happening. How will you mitigate this kind of problem? What will be your approach to resolve the data skewness?
So actually, I think after Spark 3.0, we have AQE that we can directly enable. So if we have any skewness, AQE will detect that in runtime only, and then it will try to distribute that data in an equivalent manner. So that is the sort of the first step that I would take, and I think that would fix the issue.
Okay. But even after the AQE is enabled, if you find it is still having some skewness.
So we can repartition the data frame depending on what type of, whether the repartition is costing more than.
Have you heard about the salting technique?
Yeah. So we can, salting is a sort of an advanced technique which we can use to basically we can aggregate the data based on some condition where we would suppose we have one particular partition that has a really high number of records. Then we can split that data frame using the salting technique, using the hashing table, we can say, and then we can perform the operations.
Suppose you have said that you have used the broadcast join in your project. So what is the default value of the small table that can trigger the broadcast join?
I think it's 10 MB.
Yeah, it's 10 MB. So, but for some situation, if you have to handle joining two tables, but in that case, the two tables are the large tables, so you can't broadcast any of them. How do you optimize for that kind of join when you have to deal with two large tables?
So I think in this case we can use bucketing. So whatever the bucketing column, whatever the join column that we have in both the tables, we can perform bucketing on that column, and then we have to choose the buckets in a proper manner here. And then once we have our bucketed column, then we can join it, because then it will be sorted and it will be quicker to join it.
There are many Databricks specific optimization technique which is available, which is only available with the Databricks environment. One of them is delta cache. What is the exact difference between the normal PySpark cache, which is provided in the Spark, and delta cache?
So delta cache is something that is used to optimize the speed of the delta tables. So here in Spark, what we're doing is when we are caching something, we are caching it in the memory of the cluster that we have, in the memory of the worker node of the cluster. But here we are caching it in the disk of the cluster. So instead of going to the disk of wherever our data is stored, it will be cached in the disk of the cluster. So it will like directly take the data from there instead of writing from the storage account what we have.
Okay. I just wanted to understand one thing. Spark is an in-memory processing, right? But in case of caching, you have to cache the data frame into the memory for the first processing. Where Spark, in other hand, it's already an in-memory processing, then why you have to do caching in that sense?
When we look at the memory management in Spark, we can see that the memory is actually distributed in 50-50%. So like we have a 60% to 40% split first. So this 40% is just for user memory or off-heap memory. And then the 60% is then divided into 50-50 again. So here this 50% is used for the computation that we're doing. And the other 50% is used for the storage, the caching and the processing that we're trying to do. So that is sort of the difference between both the in-memory set.
Okay. Let's imagine a situation. Suppose you want to build a pipeline. You have to fetch the data from an API endpoint. Okay? Then probably you have to first store the data in ADLS. This runs every 5 minutes, meaning every 5 minutes your trigger will poke that API endpoint, will collect the data and will store it in the ADLS Gen 2. So once there will be an ADLS Gen 2, maybe that should trigger a database job. Okay. And then probably you have to first put that data in your first layer in Medallion architecture. Then probably once the first and the bronze layer is populated, then you can process those data and create some fact tables out the gold layer. Maybe in this whole processing, if you have any error, you want to have email notifications as well. So your first task is you have to fetch the data from an API endpoint. You have to store the data in ADLS, then you have to set a trigger for that thing, and which that trigger a Databricks job. And this whole pipeline runs. After that, all the aggregation happens. We create some fact and dimension tables, maybe in Synapse, as you have worked on Synapse. And then if anything fails, you might want to trigger an email notification that should actually show from where the error is coming. So how will you build this pipeline? Just give me a brief overview of what kind of tools you're using and how they will integrate, how they will talk with each other.
Sure. So first step would be to, like you mentioned, we are fetching the data from an API. So we can either use ADF or Synapse Analytics for this. So we can create a copy activity where we would be creating a link service to this API endpoint, whatever we might have. So HTTP link service, I think. And then once that is done, we have a source created. Then we will select the ADLS Gen 2 account as our sink here in this copy activity. And then like you said, we should be triggering it for every 5 minutes. So after that, I'll come to the trigger a bit late. And then first we have this data in our storage account. Then you mentioned that we will be having some Databricks operation that will be performing on top of it. So for Databricks, we have an autoloader feature where it detects whether a new file has been added or not automatically. And once it is added, then it automatically does the processing. So we can enable that in our code, Spark notebooks. And then once we have ingested our data and once we have this autoloader implemented as well, then we can do our processing, whatever is required, and store our data in the bronze layer. So in the bronze layer, mostly it is the source of truth, right? So we do not perform any type of processing. Maybe we will just add some schema, or maybe we'll just if the source is in CSV, then we would convert it into Parquet format and delta table format. So that is some basic transformation that we would do in the bronze layer. And then we would go ahead and perform the business aggregations, whatever we have based on this bronze table. In the silver layer, so this could be another notebook, or this could be in the same notebook as well. So this second notebook would then contain the logic for grouping by, or if we are performing any aggregations, window functions, anything like that, we would include here.
Suppose the raw layer is bronze layer. You are
Hmm.
not touching anything in that bronze layer.
Hmm.
Whenever your bronze layer is updated, the silver layer will automatically copy the data first, and then maybe some aggregation will happen. So this delta table to delta table is this kind of automatic loading of data. So how can you do that thing?
So in Databricks, actually, we also have delta live tables that we can use here for this operation. So delta live tables, in delta live tables, what happens is it is sort of a whole pipeline that runs one after the other. So in fact, once we have this trigger that a new file has arrived, then on that step only, it will run the whole pipeline, whatever we have configured. So it will take the data from the storage layer, then it will perform a basic processing, put it in the bronze layer. And then we can implement the same for the silver layer as well, and then for the gold layer. So here, the difference here is that in BLT, we have to do an imperative way of writing the code where we are explicitly mentioning that this is the condition that I want, and this is the filtering condition that I want to apply on this particular table. And then we can go ahead and just run the whole pipeline. And again, this also there are two different types of deployment here. It is one is continuous deployment where it is continuously looking for a new data to arrive, and then other one is the triggered deployment where we can set up a trigger whenever we expect the file to arrive.
Okay. Okay. So, do you know something called change data feed feature in Databricks?
Yeah. Change data feed.
What is that?
Change data feed is basically it comes with the Delta Lake feature. So what it helps us with the problem that we had was whenever we are updating a record, for example, or deleting or anything, inserting. So we are not aware of what exactly was the previous value or what exactly did we update, where exactly did we perform, when did we perform this update and things like that. So this change data capture will keep a note of every change that has happened in our delta tables. So actually this makes it really easy for us to perform any type of insert update operation. And if you want to go back and check the history of whatever operations we may have performed, we can easily check that with the CDC.
Okay. As you have also worked in Azure Data Factory, what kind of best optimizations rules you should follow for an optimized Azure Data Factory pipeline?
Azure Data Factory?
Yes, is any optimizations have you done? Yes.
So I think in Azure Data Factory, we can increase the concurrency of whatever we're trying to do. So it will increase the parallelism of the copy activity or
what is the integration runtime in ADF?
Integration runtime is basically how we establish a connection with whatever source or thing that we have. So in Azure, we have an auto integration runtime, which helps us to connect with other Azure services automatically, directly. We do not need to, manually do that process. But if you have to connect to an on-prem source, for example, for a SQL DB or anything like that, then we would need to create a self-hosted integration runtime. So this self-hosted integration runtime is something that we're doing to establish a connection to a service that is outside of Azure cloud. So once we have done that, then we can connect to that database and we can fetch the data or basically perform any type of calculation that we
want. Fine. What is, do you know what is the data locality principle in Spark?
Yeah. So the data locality principle is whenever we're trying to process our data, we try to make sure that it is processed in the same cluster or node where the data is present. So instead of sending the data to the code, we try to send the code to the data so that the data is performed locally and it sort of avoids the shuffling. And Spark sort of uses that to perform better.
Do you know the difference between mapping data flow and wrangling data flow in ADF?
Mapping data flow.
These are the transformation procedures which is available in the Azure data.
No, actually, yeah.
Okay. Suppose you have two white transformation, okay, and one action was called, and probably you are handling 2 GB of data. So, how many jobs, state, and tasks will be created?
So two white transformation means 3 stages, and one action means one job. And we had 2 GB of data. So the default block size is 128 MB. So we would have around, I think, 16 partitions or 16 tasks.
Yes. What is the most challenging thing you have faced in your project as of now, and how you have resolved that? Like kind of bottlenecks, which is slowing down your pipeline, or some kind of practical issues which you have already dealt with. You can talk about.
Sure. So yeah, like I mentioned, we had this 10 partners, right? So suddenly for one of them, what happened was the pipeline was taking a little too long to run. So earlier it used to get completed in half an hour to 1 hour, and now it started taking 2.5 hours, and slowly by day it was sort of increasing. So I looked into that. I was asked to look into that, and then I sort of realized that for this particular partner, we were ingesting data on a daily basis, but this data was really small, like 100 to 200 records. So what was happening was over time, we were accumulating a lot of files in our Delta tables, in the Delta lake. And what was happening was that since we had a lot of files, like at one point we had around 100,000 files or something like that. So it was, and all of these files were really small, like 1 or 2 MB was of the size. So I just had a discussion with my senior developer and the managers, and we discussed that okay, this is a problem. This is actually a pretty common problem, and for delta tables. So we have optimize and vacuum command for this particular problem. So what then they suggested was that we need to create an optimize, and we need to create a pipeline which would periodically run this optimize and vacuum command on all of our delta tables. Okay. So yeah, so I then developed that pipeline, and then this pipeline was also configuration driven. So whenever we had any new partners that were onboarded, we can easily change the configuration, and then the same pipeline will run on those partners as well. And I also added some Boolean flags. So if we do not want to run this particular pipeline for some partners, then we can just turn that flag to false, and we can run this particular pipeline for only the partners that we require. So yeah, once this pipeline was developed and pushed to production and everything was set, then we could directly see that the performance increased from 2.3, 2.5 hours. It was taking 30 minutes now. So yeah, this was sort of the challenge that we faced. It actually took a lot of time to understand, and then we had a couple of meetings to exactly find out what the problem is. And not just that, we realized that we need to run the vacuum command before and after the optimize command to maintain the history as well.
Okay. Suppose you are getting a CSV file daily in 𝐸LSGen, and you want to load that data incrementally in your Delta table and probably do upsert on top of that. How will you do that?
We have we have a new CSV file.
A CSV file is coming in 𝐸LSGen daily. So you have to incrementally load from that CSV table. The Delta table should be like done some upsert on top of that, and you have to take the incremental data. Yeah.
Sure. So for in Databricks, for this we have the merge into command, or so this merge into, we can define the first of all the column based on which we are merging, and then if there are some matches, if it does not match, then we can choose what we want to do, basically whether we want to update the value, or we want to just like to keep the value as before, whatever it was. So we were using this merge into to update whatever new record that we were getting, and yeah, I think this would
if you like, if your requirement is you have to incrementally load this data through ADF,
ADF.
what kind of trigger you can use for it?
So in ADF, we can use timestamp actually. We can whatever processed files that we have already, we can have we can say a temporary table or a site table, metadata table, where we would just collect the timestamp of the previous processed files. And then once we have new files, we can just take the timestamp of that new file, and then we can compare, and then we can fetch the data between these two timestamps, whatever is there, and then we can perform the incremental.
And there is a specific kind of trigger in ADF which can do this job for you, which can understand
I think,
that.
yeah, tumbling window trigger.
Yes.
Yeah.
Fine. Let me have let me send you a SQL questions in your notepad. You
Sure.
can share your notepad and solve that. Let me send you the data for it. Okay. So you can see some of the number is repeating thrice consecutively.
Okay.
And like 1 is repeating thrice and 3 is repeating thrice, but 2 has only 1 occurrence and 4 is also has 3 occurrence consecutively. So you have to those data only which is consecutively repeating 3 times.
Okay.
What approach you follow, you can discuss and then you can start writing.
Okay, 3 consecutive numbers. So here, in this case, I think we can use the lead and lag function to identify the previous and the next record. And then if the previous and the next record is equal, then we can print out that number.
Okay.
Would be my approach. Something like this.
Okay. Suppose you are dealing with 1 TB of data in your pipeline, okay? And your responsibility is build it from the scratch. Like there is no cluster configuration, anything is there, you have to build it from the scratch. So what kind of configurations thumb rule you will apply to start building this kind of configuration? What kind of, basically I just wanted to know executor memory, executor ports, and the overall how many node you will, what will be your approach?
You mentioned 1 TB, right?
Around 1 TB, or maybe for the sake of calculation, you can consider this as 1000 GB of data.
Okay. So
how many
GB.
node you will choose? How many executors it will have? What will be the numbers of executor codes? It should have something like that.
Yeah, well, let me just think on that in a second.
Even if you are dealing with Databricks, you have to choose the correct Databricks cluster to handle the load, right? So what kind of Databricks cluster you will choose so that your pipeline can run in a more optimized way? So that configurations, how will you identify?
Yeah, just a second. So actually, it also sort of depends on what type of operations we are performing, whether we are performing any shuffle or costly operations or things like that. So initially, I would start with a basic cluster where I would have 16 gigs of RAM and 64 cores. And here I would initially I would set it to auto scale from 2 to 10 or maybe 2 to 20. 2 to 20 because like I mentioned, like I am not aware of what type of operation that we'll be performing. So that is why I suggested this. And like the idea here is to get as much parallelism as possible, whereas also trying to avoid the out of memory error. And we also don't want our nodes to sit idle. So we need to find that perfect balance here. And whenever we're trying to develop this, we can also take a look at in the Spark UI, and we can see the executor utilization and things like that, where we can find out whether our executors are actually being used or not. And if they are not being used, then we can reduce it. And similarly, if they are being excessively used, then we can increase the size of the cluster.
But what will be the initial number? I mean, which cluster do you will choose based on the data?
Yeah, like I mentioned, 60 GB and 64 cores. And initially, I would take around 10 to 20 nodes. Yeah, just to read the file. Yeah.
It will basically, for any kind of data, you will start with 16 GB and whatever the configuration you're telling, right?
Yeah. Any type of data, yeah, depends on what we're trying to do, I would say. That is more important. And if we're trying to just perform filter, then we don't need any high quality cluster, right? If we're trying to perform group by or partition or things like that, shuffling or caching or things like that, then we would need a strong compute. Like if we are trying caching, then we can maybe also use the storage optimized compute. If we are sure that we will never be using caching in our project, then we can use the memory optimized compute cluster.
Okay. Just a small basic questions. What is the actual difference between the Delta and Parquet?
Delta and Parquet. Okay, so Delta is sort of a file, not a file format, but it's a concept that is based on top of Parquet file format. So internally, each Delta format is Parquet only. But the difference here is that Delta Lake has introduced the concept of logs, or it notes basically whatever change we have made, and even if we are updating, we are not really updating the file itself, but we are creating a new file, whether the update will be there. So all of these logs are mentioned along with the Parquet files that we have. So that is the difference between Delta and Parquet.
Okay, you mentioned that in your project there is also some kind of data quality checks is happening. So that is before triggering the pipeline, or after you are getting the output, you are applying some data quality check to identify whether the correct output has been reached or not. So what kind of checks is there and how it has been implemented?
So these data quality checks are, like I mentioned, once we have moved our data to our storage location, the bronze location. Once the data is there, after that we are performing the data quality checks, and the checks that we're performing are very partner specific, like I mentioned. So for example, for one partner, we had this pin code column. So we would just check whether all the values in this pin code column is of length 6 or not. And then there would be other checks like date column, whether every value of this column is date or not. And then we would have some checks like, so we had this one check where all the values of a particular column should be a combination of a particular list of values. So we had this 5 values. So all the values in this particular column should be these 5 values only. So in this, if there was any suspended records and any erroneous records, so all of these records we would be sending to a different location just to have a record of what has failed the data quality check. So yeah, this is what we did initially before we were processing the data.
Okay. And what kind of code build and the cluster deployment model you have in your project? How will you move the data from development to the production? Basically, so how CI/CD has been implemented?
Yeah. We used Azure DevOps CI/CD for our project. So initially, what we would do, we would whatever pipeline we are building, we would build it manually by writing the code and things like that. But once we see that everything is correct, everything is in place, we are getting the expected data quality checks, we are getting the expected column transformations and things like that. So once that is successful, then we would be deploying it. We would actually first parameterize everything, the whatever path and everything that we would have hard coded. So then once everything is parameterized, then we would then deploy it to the pre-prod environment just to see whether deployment after deploying everything, it's working or not. So this deployment actually includes everything. If the Synapse workspace is not there, it will stand up the Synapse workspace. If the pipeline is not there, it will stand up the pipeline. If the Databricks notebook is not there, it will create the Databricks notebook. If the clusters are not there, it will create the whole cluster as well. And that is how the deployment would be in the pre-prod stage. And once we see that even the deployment is successful in the pre-prod stage, then we would get the approval from the leading parties of the stakeholders to deploy it to prod.
And suppose you are working with a new data concept, some new requirement comes in your pipeline. Are you running any kind of integration test on top of that to ensure your pipeline is generating correct amount of data? If it is happening, then where you are running those tests, in which environment?
So we have once we were sending this data to the on-prem system. So apart from that, what we had also had was a Power BI view of everything, basically every process record as well as the suspended record that I just mentioned. And out of these 5 notebooks, every single record that was rejected, we could see everything in this Power BI dashboard only. So through here is where we sort of identify what is the problem, what is the issue, if there is any.
So this Power BI dashboard, this thing is running on production?
Yeah, this is running on all 2 environments.
So until and unless it goes to production, you can't test whether the data has any problem or not. Is that something like that, or you can
no. We
the
have
problem
it
in
on dev as well, and then we have it on prod as
well. Okay, so you have the Power BI visualization in dev environment as well.
Yeah.
That is from my end. If you have any questions, you can share, or you can ask.
No, that's it. Thanks for the great feedback. I'll work on the improvement sections. Yeah, that's it.
Thanks.
Thank you.